Today we will learn about frequency polygon. In the previous video, we learned to represent classified data as a histogram. Like the histogram, frequency polygon is also a way of representing classified data graphically. In this video, we will look at two ways to draw a frequency polygon, using a histogram to draw a frequency polygon and frequency polygon without a histogram. Let us learn to draw a frequency polygons with the help of histogram. Suppose the height of students of class 9 in a school are presented in this frequency distribution table. This distribution is a continuous frequency distribution because there is overlapping of class intervals. From the frequency distribution table, we can draw a histogram like this. Pause the video and think about it. Let's go ahead. To make a frequency polygon, first we need to find the midpoint of upper side of each rectangle. Midpoint of class interval 120 to 130 will be 125. Therefore, we will go to the upper side of the rectangle drawn on the class interval 120 to 130 and mark the middle point, followed by the vertical line representing 125 on the x-axis. 125 is the midpoint of class interval 120 to 130. We also call it a class mark. Let P be the middle point obtained. Here, the coordinate of point P are 125 and 5. Similarly, we will find the midpoint of the upper sides of all the rectangles. We assume that the class interval before 120 to 130 is a hypothetical class interval of 110 to 120 with a frequency of 0. That is, the height of any student is not in this class interval. Similarly, we also assume that after the class interval 160 to 170, there is an imaginary interval of 170 to 180 and its frequency is 0. We will mark their midpoints. Now, we will connect all midpoints with the line segment. This gives us figure OPQRSTU made of line segments. On careful observation, you will come to know that this shape is a polygon whose vertices represent the corresponding frequencies of class intervals. Since the frequencies of class intervals are represented as vertices of polygon, we call it a frequency polygon. Here you can see that the triangle located outside the line graph can be arranged inside the line graph in this way. This shows that the area of frequency polygon is equal to the area of histogram. In this way, the class interval of 0 frequency helps us to equalize the area of frequency polygon equal to the area of histogram. Now you know about histogram and frequency polygons. Can you tell the difference between the two? Think. Let us tell you. Data is represented in the histogram as rectangles, while the data in frequency polygon is represented using a line graph. In the context of the histogram, we can say that the height of different points of a class interval is fixed. This shows that a class interval in the histogram has uniform distribution of frequencies. If we talk about frequency polygons, then you can see that the height of different points in a class interval is not fixed, which means that frequency polygon do not have uniform distribution of frequencies. In this way, with the help of frequency polygons, we can find an increase or decrease in frequency, that is trend. Similarly, frequency polygons also help in comparing two different figures of similar nature. Now, let's know how to make a frequency polygon without histogram. Here also, we will take the first class interval 110 to 120 before class interval 120 to 130 whose frequency is 0, and similarly, after class interval 160 to 170, we will take class interval 170 to 180, whose frequency is also 0. To make a frequency polygon, we need the middle point called class mark of the class interval. Therefore, we will get the class mark of each class interval. Class mark of class interval is equal to upper limit of class interval plus lower limit of class interval divided by 2. Therefore, class mark of 110 to 120 is 115. Similarly, class mark of class interval 120 to 130 is 125. Similarly, we will find the class marks of all the class intervals. Now, we will draw x-axis and y-axis and represent class marks on x-axis and frequency on y-axis. Taking an appropriate scale on both axes, we will represent different points taking class marks as x-coordinates and its corresponding frequency on y-coordinates. Here, we will represent point O with coordinates 115, 0. Similarly, we will represent other points like this. Now, we will complete the frequency polygon OPQRSTU by connecting all the points with line segments. In this way, we can obtain a frequency polygon even without a histogram. The table below gives the class interval of different widths and their frequencies. Try yourself to represent it in a frequency polygon. So today we learnt about frequency polygon. We will see some interesting examples related to it in the next video.